Hi friends, welcome back. Now the next question to look at is how to turn off switch number 3. Yeah, that's a situation we have. Uh, these are the positions of the different switches 0, 0, 0, 1, 1, 0, 1, 1. So and now we are asked to find out how to turn off the switch number 3. So turning off switch number 3, what is required is we need to AND. So when you say turn off, then off is related with AND with a 0. So this has to be AND with a 0, and you don't want others to be disturbed. Therefore, keep others to be 1, and when you create this mask and use it to AND with our data, 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0. So that means what has happened in all, if you look at it, is only this one thing has changed. The rest all are remaining same. So what we need to do is, if you want to switch off the bit number 3, then make sure to have 0 in the mask at that 3 position, and all others should be a 1. So how do you get that? Yeah, you can try to use the same old logic we did as. So take a 1, then you want to go to the third position, so shift it left to, sorry, so take a 1, this one you shift left by 3 positions, so that makes the 8-bit position to be 0, 0, 0, 0, 1, 0, 0, 0. So that's gone here. But what we want was the opposite of it. So if you take a NOT operation, then this will be 1, 1, 1, 1, 0, 1, 1, 1. Yes, the mask is ready. What do you want to do? So the process is simple. You want a nth bit to be off. So then take a 1 and then shift that 1 to left by 3 positions. Then take the inverted version of it. So apply NOT and then use that and with your data. So that was our data. So this data is ANDed with our mask. So after NOT, we get a mask which we use to AND. So that is for third bit. So in general, an algorithm, we could say take a 1, shift left by n positions. So that means 1 shifted left by n positions. So that makes that particular position 1, all others are 0, but we want the other way. So use NOT operation on this mask and that will get us the mask and our just generated mask with the data, and that will turn off nth bit of data. So that's how the bitwise operations can be performed. So one is to switch on particular bit, then this is to switch off a particular bit. So what if we have a very large number of data which can't be fit on one position of the memory? Yeah, that's our next issue to look at. So in our next session, we look into this issue when the number of data are very much larger. So here we had considered that there are only 8 switches, so we could use 1 byte for representing it. But if there are hundreds of switches, then we can't work with hundreds of bits together as one unit, because there is some limitation in the memory. The memory usually is measured, built in terms of bytes, and if you're working in any processor, then depending on the processor, each unit of data is either represented by 8 bits. If it was 8085, it is 16 bits. If it is 8086, and then it became 32 bits in the higher version. Later it has become 64 bits. So today we may be working with 64-bit processors. So that means when you say a data, it is having 64 bits. But when you talk of memory, then you are having the basic memory is in terms of bytes, but one full data means 64 bits. Then how can we work with these all? Let's see in our coming sessions. Okay, till then, take care. See you. Bye.